You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Fraser Cain, creator and publisher of Universe Today, one of the world's largest portals of space and astronomy news, with over 140,000 subscribers. In 2006, Fraser joined with Dr. Pamela Gay to create Astronomy Cast, which is among the top-rated and most popular podcasts in the natural sciences. Remember to subscribe to Event Horizon so you never miss an episode.
Fraser Cain, welcome back to the program.
Good to be back.
Fraser, in all of my years in explainery regarding astrobiology, I've never wavered from a single mantra: don't scare the aliens. And I think we are very much in danger right now with something called eels in scaring the European space whale, should it be there.
Right.
I have never seen a concept like this, but I absolutely love the idea because we are dealing with a truly alien landscape, which is the surface of Europa. Well, alien unless you go to the Arctic. And we have a way to do that, which is something that I always wondered about. You know, you remember we were talking about melters and things like this. How do you access that ice? But this is a really cool idea. Give us an overview of EELS.
Yeah, so EELS is a robotic probe being developed by NASA, and it's designed on the concept of a snake. So it articulates in the way that a snake does by sort of running a wave down its body, and it's able to sort of rotate itself forward along the ground. And what's great about that is then it can move across a variety of terrain: sand, rocks, and ideally snow and ice. And in some of the videos that you see from NASA, like some of the stuff, like they're imagining what it could be used for, you're seeing this thing slipping down into the geysers on Enceladus to explore the sources of the tiger stripe geysers on this icy world. But they actually tested this. So they actually took this to Glacier in Canada, in the Rockies, and tested out the concept. And we're able to prove that, yes, indeed, this thing can locomote, move around. It's got to have a lot more artificial intelligence, its own ability to pathfind. And so you can imagine this thing is crawling around on the surface of Mars or Europa or Enceladus, and it is finding its way around various rocks, climbing up steep embankments, down other things, slipping down into lava tubes to explore. It's a pretty great concept. There's a lot of amazing rover concepts that have been developed. There was one that NASA tested out on the underside of the ice in Antarctica. So they ran this rover like a car upside down around on the ice. And so this could be something that they could test on Europa or Enceladus as well. If you could actually get down under the ice, then you could drive around with, floated, pushed up against the top of the ice. So there's a lot of really great ideas. I mean, people are excited by the helicopter on Mars right now, but there's probably 10 different concepts for flying vehicles that have been proposed for Mars alone, not to mention all the really cool ideas for Venus. So there are some really clever ideas for rovers and flyers and crawlers and jumpers and squirmers out there. Slitherers, yeah.
Yeah, slitherers. But it's interesting because it takes a lot from nature. In other words, if you look at it, it looks like a snake, and it looks that way for a reason. So you almost see sort of nature being mimicked in our probes, or for example, like a Mars rover, 6 legs, like an insect, So there's these engineering that almost seems inspired by nature. And I think that that's particularly cool, especially when you're dealing with something that is explicitly designed for exobiology, as EELS is.
Yeah.
It's looking for extant life. And this is another interesting aspect because it means now we're back into direct probes into finding life in the solar system. Do you agree with that approach?
In directly searching, sure, yeah, of course. I mean, all the places. I think we should look everywhere. So yes, I think we should look directly for life on these worlds. I mean, like Enceladus is such a gift because it is this icy world, just about 500 kilometers across, almost all water ice, and we know because of the tidal interactions with Saturn, it is spraying its oceans out into space. And we saw these amazing images from JWST this week, seeing one of the plumes that's been released recently. And you've got the raw material for life. You've got the water, but also embedded in these plumes, you've got hydrogen gas, which bacteria is perfectly happy to eat. You've got other more complex molecules embedded in these plumes as well. And so you could send a spacecraft to Enceladus and just have it sort of stick its snout into the plume and sample what's coming from the underwater ocean on Enceladus out into space. And maybe you could find organic chemicals. Maybe you could actually find life. Yeah, I mean, that's why astronomers are so excited about Enceladus and Europa. I mean, I think Enceladus is more exciting than Europa. Europa's great, but Enceladus, like, we know this water is going to space.
We know, and we also know it contains nutrients. I mean, it's already been established.
Yeah. So it has bacteria food in it, and it has warm water. Like that place would be completely inhabited if it was on Earth.
Yeah, which brings up the question. I mean, if you have the interchange of that ocean underneath the ice shell spraying out into space, so that's one way interaction. Does the interaction go the other way? And does material from space end up inside the ocean? In which case we find cousins.
Yeah, this is one of the questions that astronomers are looking at with Titan. So Titan, we know, has these lakes of liquid methane, it rains methane. And then the surface of Titan is like ice. The mountains and the sand are made of ice, but it also has a liquid ocean underneath all of that ice. So it's like a 3-layer cake. The outer layer is this hydrocarbons, which is like the raw material for life. And then you have the ice layer, and then under that you have a liquid ocean. And it's believed that there are processes on Titan that are shifting these material, that are pulling these hydrocarbons into the center of the world under the ice, and where it's mixing up with warm water, and then it's making its way back out onto the surface, and you've got these cycles. And you could very well be that you have similar cycles on Europa and Enceladus. Like on all of these worlds, their surfaces look very fresh and smooth and not ancient. It means that there are the equivalent of plate tectonics, or some kind of process that is resurfacing them and pulling material from the surface down below and then mixing it back up like a Zamboni. I think like a space Zamboni that is cleaning off the craters in between large impacts.
And it's amazing because it's in the case of Europa and Enceladus, it's both of them. We see this active geology, this active surface interaction, to the point of even cracking open, apparently. And for a short time, liquid water on the surface, for a very short time, and then it refreezes.
Right.
And it looks like the Arctic, here on Earth, where you get these mishmashes that form and things like that. It's just that they can't keep it liquid on the surface, whereas Earth can. But the idea, though, of getting the eels into the ice. Now, what's the idea there? I mean, does it have some kind of a melter feature or something like that? Or is it just going to go right into the crack?
No. And it's going to go right into, so if you look at the NASA videos showing some of their illustrations of what's going to happen, you see the thing slithering down the crevice through the water. As water is upwelling from the interior of Enceladus, you've got this snake bot slithering down to sample closer and closer to the source. I mean, I think power is going to be an issue. Here on Earth, they ran an extension cord to it. I wonder how they're going to maintain the power. If it's going to are they going to keep a tether connected to it? Is it going to have an RTG, which is a fairly big, bulky object?
Big, bulky, heavy piece of plutonium.
Yeah. I mean, there are some ideas for smaller RTGs, things that will run hotter and faster, but don't have the same kind of half-life. Like, you don't just have to use plutonium-238. There's a lot of options for nuclear fuels if you want to run an RTG, and some could make for a smaller power plant. But yeah, I'm not sure how they're going to keep this thing powered. I mean, Right now they're just testing the locomotion.
The other thing, too, is getting rid of the heat, because you're going to affect the local environment if you've got a big hot piece of plutonium decaying there. That's got to go somewhere.
Yeah.
So you have to wonder about...
Well, I mean, you've got water coolant all around you. I think you'll be okay. And it's bound for space. So I think you'll be all right.
Still, I worry if we run into the European space whale, it's either going to be terrified by this thing or attracted to it, in which case neither scenario is good.
Yeah, or pity us because of our lame technology.
Or it sends one of its own.
Yeah.
It says, all right, you can play it this game.
Exactly, yeah.
And then all of a sudden there's alien eels everywhere, out in the yard like an errant weed.
Right. I mean, and the European space whales, of course, would run a very sort of aquatic-based space exploration program. So I think they would be right at home exploring the oceans of Earth.
They would be. Now, the harder ones. Ice shell moons obviously are not rare. We have oceans under ice seemingly at a number of bodies, but some of them are going to be much harder to get to and a lot weirder. For example, Ganymede. Has anybody put any thought into how one might explore an ice shell ocean like that?
Yeah, so I've been really excited about Ganymede. I'm calling Ganymede the new Europa because it has all the same stuff that Europa does. It is the largest moon in the solar system, so it has the most gravity. It has a thick ice shell around it with a liquid ocean underneath. And the additional thing that it has is that it has a magnetosphere. It actually has an internal dynamo that creates a moon-wide magnetosphere. But we don't know if there are geysers on Ganymede, and this is what ESA's JUICE mission is going to try and find out, which just launched, was able to successfully deploy its ice-penetrating radar system, and is expected to arrive in the Jovian system in 2031. And it's going to map out the sub-ice structures on Ganymede, on Europa, and on Callisto. So we don't know. Like, if we really luck out, then the same kind of structure that we see at Enceladus, where you've got these fissures and cracks that run from the ocean up to the surface, are present on Ganymede and Europa and Callisto and Pluto and all of the moons of Uranus and Ceres. Like, this is a common feature. It's believed there are many more of these ice worlds across the entire solar system. So I think the hope is, thanks to JUICE, we will see the internal structure of Ganymede and then know how to proceed from there. So it's too early to tell right now.
So what's going to take JUICE so long to get there? Why so much of a latency problem? Which I know the answer, but explain that. But the other thing is, didn't it have a hiccup?
It did, yeah. So the hiccup that it had was that it wasn't able to deploy its radar antenna. So it's got this 13-meter long radar that was folded up many times, and then it would release this pin and the thing would snap out kind of like a tent pole, right? And so they deployed the thing and it only got partway out and then it stuck, and it turned out that one of the pins that was supposed to extend didn't release. And so they tried to go through a bunch of ways to fix it. They accelerated and decelerated it. They tried changing the orientation of the spacecraft so that the temperature might warm the metal and change it. And then in the end, they hammered they had a mechanical percussion thing on the spacecraft. They hammered that ran vibrations down the antenna, jiggled the pin, and it came unloose, and then it was able to deploy the antenna fully. Yeah, the trip takes a long time because you have a smaller rocket. So if you have a really big, really powerful rocket, then you can do a direct flight out to the outer solar system. And originally, say, the Galileo spacecraft was supposed to launch on the space shuttle, and they were going to have this really fantastic upper stage, and they would have done this straight shot for Jupiter. And then because of the Challenger disaster, they changed the rules on what they could hold as an upper stage of the space shuttle, and so they had to shift over Galileo to I think it was an Atlas rocket, maybe it was a Delta. Anyway, it didn't have the same kind of juice as what the original upper stage they were going to fly with launch from the space shuttle would have. And so they had to come up with a new way to get to Jupiter. So in order to still complete the mission, they figured out a new kind of flight, which was that they make flybys of various places in the solar system. And they realized that you could do a flyby of Earth and do a gravitational assist of Earth. You could do a flyby of Venus, get a gravitational boost from Venus, and you could make your trip out to Jupiter. It would take you longer, but you could do this with less energy. And that longer flight time is being used for multiple spacecraft now. And so a lot of the times they're able to get more mission on a smaller rocket than used to require.
Speaking of Ganymede and how it actually has a magnetosphere, this speaks to something else that's recently developed within the realm of the possible, searching for planetary magnetospheres and giving us a new way to do searches for exoplanets, including possibly small ones. What's the deal with that? Give us an overview of this new idea of searching for magnetospheres.
I love this idea. Like, imagine you look at a star system and you wait and you hear a radio burp, which is coming from a solar flare from the star hitting the magnetosphere of the planet and causing auroras. We get this here on Earth. And so you didn't even know that there was a planet there, and then suddenly you see this radio signature that comes from the interactions between the star and its planet. And then suddenly, not only do you discover that there's a planet there, but you also find out that it is protected by a magnetosphere, which of course, life on Earth would be vastly different if we didn't have the magnetosphere that protects us from cosmic radiation and solar radiation. And this has now successfully been done. So astronomers were able to detect the telltale signature of an aurora blasting off of an exoplanet, and then they were able to do follow-on observations and confirm the existence of the planet. So, and in fact, a magnetosphere has been mapped around a cool red dwarf star as well. So the next generation of radio telescopes are just getting so powerful, so capable, that we're getting to this place where we're able to actually make these kinds of detections. And the best place in the solar system to put a telescope that would allow you to detect many, many more of these is on the far side of the moon. And so there's been some really interesting proposals that are quite far along at this point. There's one called Lunar Farside that would aim to build a radio telescope on the far side of the moon, and then you would use that to scan the dark ages of the universe, but also potentially detect the aurora activity of planets that are interacting with their stars. And so it's like a twofer, right? Like you not only discover the planet, but you discover a planet that is protected by a magnetosphere. It's awesome.
But this also brings up a question. Are there aliens out there looking at our magnetosphere?
Right.
So has Earth been broadcasting its existence, not only its biosphere, but other things for a very long time?
But like that, I mean, that is, we have broadcast our existence out into the universe for a very long time.
Sawdust.
Probably, yeah. Like life itself, when it got going 500 million years ago and filled the atmosphere with oxygen, demonstrated to the universe that there's probably life here on planet Earth. And then when we entered the industrial age, we were able to put out pollution into the atmosphere. When we entered a more modern age, we put in chlorofluorocarbons into our atmosphere. We began global warming. There have been nuclear tests. Like, the list just goes on of all of the things. But yeah, absolutely, that for however long the Earth's magnetosphere has been present, aliens could be watching our star system and go, oh, there's a planet there. Oh, and it's protected by a magnetosphere. And oh, it's in the habitable zone. Interesting. We should send some spacecraft to go check it out. Send the Greys.
Send the Greys. Views on about that. Have you been monitoring the NASA probe into UAP? And if so, what do you think?
Barely. That story kind of just broke late this week, and so we just did some initial reporting on it, and I haven't really done too much of a deep dive. The gist that I got was, NASA, well, like the military has done its probe into UAPs, and then NASA began its own independent probe, and they had 16 experts, including a bunch of scientists and Scott Kelly, which is awesome. And they're looking for just any kind of way to bring their expertise into what they know about spaceflight and advanced aircraft to the conversation. And the issue that they really highlighted was just a lack of good data. That there are hundreds and hundreds of reports, and most of them are easily explainable, and the ones that remain, the data is just really mediocre. It's always right at the very limits of what you can and can't see. So they didn't find any evidence of aliens, but they're not complete yet. They just gave us sort of a report on where they're at so far. But I think the biggest hope for all parties involved is that there is better way to categorize the sightings, better instruments on board various aircraft, spacecraft, better ways to process that information and keep it, then preserve the data so that people can study it afterwards. But yeah, so I know like a lot of people out there were just like hoping that this is it, right? Astronauts are going to be looking at for UFO data, and no, so far, nope.
Well, they will be looking for data, though. That was the one takeaway that I had, is that they're going to, at least what they say, is take a serious attempt at collecting a good data set, and then try to figure out exactly what to look for, because you're looking for something by nature is unidentified, so you have to try to figure out what you need to look for, which obviously involves a lot of the public, really. The people that report these things need to say, what other than interacting with light, because you can tell if there's an object in the atmosphere and it's reflecting light, that's the only way you're going to be able to see it. So it's active in the electromagnetic spectrum, or at least reflecting it. But it was all about methodology and how you might assemble a data set, a quality data set, so long as you know what to look for. And what they'll do is train an AI or something like that to look for things that are very out of the ordinary, strange movements and things like that. And that's what I took away from it, is that it's very preliminary still, and they're just thinking about how to look. And the big clear thing is a good data set. One interesting thing, though, you mentioned Scott Kelly, and he actually told a story that I was unaware of, you might have been, where one of the space shuttle missions was trying to close the bay doors of the shuttle, and they saw a light, and they thought, uh-oh, that's an errant bolt or screw or something. And the shuttle was, for its own structural integrity, it can't exactly, smack into a bolt as it's closing its doors. So they held it, and it turns out it was an optical illusion, and they were actually seeing the ISS from hundreds of miles away, and it looked like a bolt hovering. And I found that story particularly interesting because I hadn't heard that one before, but it was direct from Scott Kelly.
Yeah, I didn't hear that. That's really cool.
Yeah, that was actually one of the most interesting parts of it was that story, because, well, who doesn't like space shuttle lore? But anyway, yeah, I just wanted to touch on that because it's a subject that needs to be taken seriously, and we need to identify the unidentified. But
yeah, it's always, we talked about this last time, right? Which is that it's always cost benefit analysis, which is like, how much are you willing to invest to identify the unidentified? And so if there's the Galileo program, which I'm sure you're familiar with Avi Loeb and others, who are trying to build really comprehensive network of sensors around the world to detect this kind of stuff. That's going to cost a lot of money. To do a really good job, it's going to cost millions and millions of dollars. So how much of a priority is that versus sending snake bots to Enceladus?
Well, that's always a big question. Yeah.
Yeah, and I think that's like I think for most people, everyone's going to have a different opinion about where they land on that. Like, would you be willing to spend billions and billions of dollars to understand UFOs when there isn't a single unexplained, or I guess anything that is clearly has solid data that it comes from outside this solar system? How much are you willing to spend?
Yeah, well, what is there isn't convincing. Admittedly, it isn't convincing.
No,
it's not impossible for an alien presence.
But like,
impossible.
How much you want to spend? And that's the question, right?
That's the question. Yeah. I think that it's worth, given the public interest, I think it's worth some. But there is eventually going to be a limit where, if you don't see anything, and I'm qualifying that and saying if, because if they find some object of alien origin then yes, it was worth it. Automatically. All you need
totally.
is one.
And let's spend more.
Or
right?
let's.
Right? Like if we find something that is of alien origin, then let's spend all of it.
I would say spend all of it on getting rid of it. Kicking it out of the...
No, but like understanding it, finding more of it, understanding the implications of it. Like, yeah, if we find something that the world experts agree is of alien origin, that changes everything.
It does.
And suddenly it needs to be the most important thing that we do. But right now, we haven't found any. And so how much are we willing to spend? Against other avenues.
Against other avenues.
How much do we spend? How much do we spend on eelbots, and how much do we spend on searching for technosignatures, and how much do we spend on SETI, and how much do we spend on examining the atmospheres of exoplanets? And like some are very like slow and steady, kind of boring. Like, yeah, you examine the atmosphere of an exoplanet, we get better and better at it, we detect the presence of oxygen, and we compare it to other chemicals, and we can say with some level of uncertainty that there is some kind of life on this planet. That is the slow and steady wins the race, right? Or like the way.
Well, but if you slow and steady wins the race, and the other thing is that once you establish that beyond a reasonable doubt, if you were to see an exoplanet that had unnatural oxygen levels and looked like Earth and was in that same disequilibrium, and you were able to say this is a biosphere, then that tells you everything you need to know about life in the galaxy, because it's everywhere. If we detect it, it's everywhere. It's at that point.
Yeah, totally.
In which case you could then start asking the question about the UFOs again, because if you've got a lot of life in this galaxy, then, or you get a SETI signal or something like that, then you start having to ask the maybe questions, a little bit harder.
Yeah. Then where is everybody?
Yeah.
Yeah.
Yep. So onward. So searching for exoplanets and their magnetospheres, as we covered, also is the elephant in the room, JWST, and its search for exoplanets. Has there been any development any developments from JWST regarding anything Earth-like yet, as far as an exoplanet atmosphere, and what have we found so far?
Yeah, there's been nothing Earth-like. The closest that we've gotten so far is that we know that JWST has examined the atmospheres of the TRAPPIST-1 worlds, and these are some of the most exciting ones that we know of course. You've got 6 planets orbiting this one red dwarf star. 3 of them, I think, are in the habitable zone around that star and are really interesting. And about a month ago, we got the first planet. So we got TRAPPIST-1b, which sucks. It is super hot, not in the habitable zone. It's like a Venus. And so we got really interesting analysis of the atmosphere of the planet and like a lot of the kinds of stuff you would want to know about another world. Okay, great. But they're clearly going to just dribble out the information to us one planet at a time. So, I think we talked about this last time as well, that the astronomers who get access to JWST, they've got a year to release their data. And so they can release it sooner. And if they hit the 1 year mark, then their data goes out into the public domain, and then anybody can do analysis on it. And so they've got that ticking clock. But we got the one planet. But there's been a lot of other interesting planets that have been seen. Most recently, the one this week was this world, WASP 18b, I think.
18b, I believe, yeah.
Yeah, which is a hot Jupiter. It has about 10 times the mass of Jupiter, orbits a star that's a little more massive than the sun, and it has like ludicrous temperatures. And they were able to watch the planet as it went around the star, and they were able to measure the temperature of the planet itself. And they were able to just figure out that, yes, the planet is tidally locked to the star, that the day side and the night side are about 1,000 degrees off from one another. They were able to detect the presence of water vapor in the atmosphere of the planet. Of course, it's not habitable. It's like steam, like you boil alive. But still, you've got this planet that is orbiting this star, and they are measuring the temperature, and they are seeing how heat is transferring from the day side to the night side. So there's been a couple of other worlds. They've detected various atoms, sulfur dioxide. They've detected carbon dioxide, carbon monoxide. So they're working on it. We've just hit 1 year-ish of using JWST. I mean, not even yet. So people have to be patient because we've probably got another 20 years of this.
Has JWST so far exceeded your expectations?
No. No, I feel like it's done the job it was meant to do and done it well. It has found galaxies in the early universe. It has peered through the gas and dust to see newly forming planets. It has looked at objects inside the solar system. I mean, I'm really pleased with the degree of accuracy that they've gotten out of it, that it has met all of their spec and more so. And like whenever you have a powerful new telescope, you're going to find new things and you're going to overturn upheld theories and you're going to just like push your science farther. So I'm not like, this is just what you get every time. Like when the Vera Rubin telescope comes online, when the Nancy Grace Roman telescope comes online, when the extremely large telescope, the Giant Magellan telescope, Euclid, like there's all these next generation telescopes coming, each one designed for a very specific job. Then it's going to dump the Lego blocks in front of you. You know, I always sort of imagine this, you know, you're like ready to play with your Lego and you just dump them all in front. And then you got to dig through and start pulling together objects. And so the scientists are going to have to start digging through all this data. It's like a fire hose at this point.
Yes, but data is good. And as much of it as you can.
Data good. More data better. Yes.
Franken telescopes. The idea of not only launching new telescopes like the Nancy Grace Roman, which is a repurposed spy satellite mirror of all things.
Yeah, like a Hubble.
Bringing back Spitzer. There exists a plan to bring that telescope back from the dead. Tell us about that.
Yeah, so the Spitzer Space Telescope was a long-running telescope, and it was into the far infrared, so even beyond what JWST does. And it was able to do that because it had liquid nitrogen coolant on board that was able to cool its sensors down to just a few degrees above absolute zero. So it was able to observe the universe, and it didn't have the size of JWST, but it had that ability to see those wavelengths. And then it ran out of the coolant and it switched to a warmer phase where it tried to stay as cool as it could based on the ambient temperature of the universe and observed for a few more years after that. And then it finally died. And it is still in orbit around the sun and is theoretically still a fully functional spacecraft. And so a private group has proposed that they get paid by NASA to go out and retrieve the spacecraft. And so NASA has sort of has asked for a feasibility study to retrieve Spitzer, refuel it, reservice it, put it back into operations, and we could see many more years of Spitzer operation, which would be great. It'd be amazing.
After what? I mean, that thing operated for 17 years successfully, something like that?
Yeah, it's one of the great observatories. Like it is in the same class as Hubble, Chandra, the Compton Observatory, and Spitzer. So it is one of humanity's greatest instruments. And again, seeing wavelengths of light that no other instrument can do, especially when it had its coolant on board. So it would be great to have that back on operational.
Now, does that offer, say we do that and we can do it successfully, does that offer any hope for extending Hubble?
Well, I mean, Hubble's a separate issue, and there have been some private offers to try and boost the Hubble Space Telescope as well. And so we could see that Hubble gets boosted and then maybe has other additions, modifications made to it, fully robotically this time, as opposed to humans doing it. And so you could see its mission getting extended. But I mean, like, it's getting old, right? It is 30 plus years old and has been delivering so much science, but it can only last for so long. How many cosmic rays will it get hit by until it finally stops working? You know, we've known that its reaction wheels had to get swapped out. But yeah, there are proposals to extend it. And I think all of this is under the shadow of the SpaceX Starship, because these ideas are being planned using a very conventional system. Like you launch a cargo Dragon with manipulators on board, and you meet with the spacecraft, and you dock, and you deliver you deliver various instruments to it. But Starship is next level. Like Starship could go up and just gulp down the Hubble Space Telescope or gulp down Spitzer and carry it back home. And then you could do work on it on the ground. You can imagine if the engineers could get their hands on Spitzer and then completely refurbish it on the ground. And I think that we're going to get to this place. Like if Starship works, I mean, we're still, the jury's still out on that. But if it works, then it's going to quickly burn through the world's launch manifest. It's going to launch all the satellites, all of the spy satellites, all of the communication satellites. Everyone's going to get their satellite networks, and they're going to go like, what else are we going to do with this thing? Let's go and grab historic missions and let's see if we can refurbish them. And so you can imagine a SpaceX Starship flying out, gulping down Hubble, bringing it home, and them completely renovating it and upgrading it, and then launching it again. That would be awesome.
Or for that matter, putting it into the Smithsonian or something, going out and retrieve some of the early craft. Oh, you want to keep that poor telescope in service for the next 100 years.
Yes.
Dragging it back. Well, once AI comes along.
Yeah. Are you kidding? It's a classic. Are you kidding? Like at this many orbits, it's just finally starting to really run smoothly at this point.
Well, with the advent of scary artificial intelligence, integrating that into the Hubble Space Telescope may eventually prompt it to take its bitter revenge with the giant space laser that somebody installed on it on its 100th birthday. Does AI scare you at this point?
Yes.
Or do you just say, oh, it does?
Yeah. Oh, yeah. Oh yeah, absolutely. I am, like, what is my P-Doom? High. My P-Doom is high. Yeah. I'm fully bought in that AI is an existential risk, that we are careening towards building a machine that is smarter than us, and we have no idea how to control it.
Do you think it happened faster than we could have predicted it would? It
Yes.
seems to me to have happened about 20 years faster than I thought.
Yeah. I mean, I think nobody expected the transformer model to be so effective that you would get these kinds of capabilities arising out of it. And each, like, it's hard to keep up on top of it. Like, I spend a lot of my time every week staying abreast of artificial intelligence news, and it's amazing how quickly this stuff is coming fast and furious. Like we could stop, like OpenAI or Google could stop training models today, and we would probably spend 10 years digesting what they've done. Just having this technology make its way into every single part of its operations.
Well, that's one of the aspects that scares me is, all right, so we sit there and we monitor space news for our living and science and technology news. And the thing is that it's not so much that it's speeding up. It's also exponentially growing. The amount of AI articles that I read each week is far more than it was 2 years ago. And it's all relevant news that,
Do you mean news about AI as opposed to articles written by AI?
Or by AI, and which is going to become impossible to tell at some point.
Well, I mean, this is already a gigantic problem for the two of us, because there are channels across YouTube, and Kyle Hill made a fantastic video about this, that are just gibberish, that are an hour and a half long of beautiful images from space written by artificial intelligence, and it's just this nonsensical gibberish that goes on for an hour and a half and has 2.5 million views.
It does, because the algorithm thinks it's legit.
And people watch this, and it passes the smell test, and they just watch it, and they watch it, and they watch it, and it's just like, and astronomers with JWST peered into the center of the universe, and they saw God. You're just like,
right? Yeah.
It just goes on and on and on for 2 hours, and like, it's incoherent. Like, I've watched a couple of them just to figure out how bad this problem is, and it's like, these are terrible, and they are, and like, I wish I had the kinds of stats that they do.
I know, and the other thing is that you are literally watching an artificial intelligence hallucinating about space.
Yeah.
I mean, that's the actual term for that, is a hallucination.
Yeah.
Imagine how our comment sections are going to go as people take that stuff as fact, that it's not real.
Yeah, it's like the new rabbit hole. So this will be our new flat earthers. It'd be someone's gonna be like, yeah, but I saw in this other video, they said that astronomers found God in the Booties supercluster void with the Large Hadron Collider, and they sense the gravitational waves. How do you explain this?
All you can say is an artificial intelligence wrote it. I mean, that's all you can say. But I mean, there's also, I imagine a prominent comment you get, because I get it all the time, is that the Big Bang didn't happen. and that there's a growing movement against the Big Bang. The problem is that nothing else explains what we see, the observations that support it. So
I just covered this in one of my question shows, and I think the thing that's most important to understand is that the Big Bang does not explain the beginning of the universe. The Big Bang is about after the beginning of the universe. The Big Bang just says galaxies are moving away from us today, so they were probably closer in the past, right? And the analogy that I always use is you're driving down the road and you see a car coming the other way, and you go, that car, it came from that way. And then your friend goes, so are you saying that you know that the car was made in Japan? And you're like, no, I'm just saying that the car came from that way. That's it. And so the Big Bang only says that the universe is becoming less dense over time, so it was more dense in the past. Was it created by a cycle of a previous universe? Maybe. Was it created by brains colliding with each other? Maybe. Was it made from inflation? Maybe. Was it made by God? Maybe. Are we in a simulation? Maybe. Big Bang has nothing to say about any of that.
Well, that's a mistake that's made, but also that when the idea of the Big Bang first came out, was starting to be formulated by Lemaitre and those guys, based on originally on observations by Vesto Slipher of redshift, that these galaxies are, they're moving away. And that's where it started. But there was a lot of blowback from the scientific community against the Big Bang initially. And people like Fred Hoyle never gave up the steady state theory.
Yeah, I mean, the very name Big Bang is a insult by Fred Hoyle.
Yeah. Yes. And that, so it was never monolithic. It's just that it's congealed around it because there is so much evidence of the Big Bang at this point. But that doesn't mean that we fully understand the aftermath and what unfolded. That's still open to a large degree because there's just no observations.
Yeah, I mean, there are beautiful, beautiful pillars of evidence that hold up the Big Bang, that the universe is less dense today and was more dense in the past. That you see galaxies moving away from us in all directions, that you see the ratios of hydrogen to helium in the universe, as well as lithium, beryllium, other trace elements, that you see the cosmic microwave background radiation, that you see large-scale structures in the universe at different times looking as if they are being pulled together by gravity. These all show that the universe is getting less dense over time. And it only lets you get back to a few milliseconds after the beginning of the universe. But what came before that? No. But yeah, like JWST, people are definitely quite excited by the observations of JWST, seeing these impossible galaxies that are too big too soon. And they're hoping that finally their pet theory for the beginning of the universe, or how they're going to overturn the Big Bang, will come true. And unfortunately, their theory has to explain all of those other pillars that we see in the universe as well. Like, great. Explain the abundances of the different elements, explain the cosmic microwave background radiation, explain that galaxies are moving away from us in all directions, fit that in within your theory, and then make some predictions about if we look in some weird way, we should see something about the universe. Then Nobel Prizes all around.
We also don't do ourselves any favors when we start branding things like a crisis in cosmology. When in fact, no, that's the good stuff. That's a discrepancy. Yeah. The discrepancy tells you new physics might be found here. And I think those apocalyptic terms like crisis just don't do us anything.
I love it. I think it's great. I love it. Yeah. I no longer care. I just don't care to convince people who are unwilling to look at this kind of stuff scientifically, and who appreciate that as new evidence is gathered, you shift your perception of what's going on.
All science is a learning experience.
Like this,
forever.
Yeah. All science is a process, and that's why you get it's safe to drink coffee. It's not safe to drink coffee. It's safe to drink coffee. Is it safe to drink coffee? Like, that's because scientists are doing studies and they're finding their way towards the truth. Ideally, they're trying to study the data, and they're trying to build these theories. And one group will realize that another group made a mistake, and then they'll fix that mistake. And so I think it's fine. And I think, I mean, it's almost like it's clickbait, right? Like you say, this is a crisis in cosmology. What do you mean by the word crisis? Well, what I mean is amazing, exciting opportunity to discover new physics about the universe.
Well, the other thing too is that that's what excites scientists, is when you find that stuff, the discrepancy.
Yes.
That's where they get excited, because that's where new work is ultimately.
Yeah, and that's the other comment that I'm sure we both get is that someone will say, well, scientists are so set in their theories, they don't look at new evidence, they treat this almost like it's a religion, and like that couldn't be more wrong. They can't wait to be wrong, because that means that you learn a little bit more about the universe, how it truly is when you are wrong. Scientists love it. And I think that the public doesn't appreciate that, doesn't understand how wonderful it is to be wrong. And we get moments of this, like I don't know, like you think you've left your keys somewhere, and you're absolutely certain that you left your keys in this place, and then suddenly you find them somewhere else, and you're like, oh, I'm so glad that that I did find my keys. They're not lost. But yeah, I think scientists really enjoy this process because it gives them glimpses into how the universe really works, and we would much rather move forward in the universe knowing reality than some preconceived notion about how things work. Just keep an open mind.
Where it gets really good is when you're looking at one thing and you answer that, and then all of a sudden something else clicks.
Yeah.
You learn some other aspect of the Big Bang that you were wondering about. All of a sudden you have an in.
Or even that you just have 10 more questions. You get one question answered, and now you have 10 more questions. That's also exciting.
New mysteries. Yeah, mysteries. And they show up. I mean, people ask me, like, when are you going to run out of subject material on your original channel? And I'm like, when I run out of mysteries, because there are more being created than I can
totally
cover,
Yeah, and it's funny because like the better I get at this job, the better being a journalist, the more I'm able to just spot these mysteries and see what makes them so compelling. And my job is to convince other people why these mysteries are so exciting and so interesting.
My favorite part is when you run across something in the history of astronomy after all of our decades of amateur astronomy and all that you didn't know about. Mm-hmm. For example, there was I believe, an observation by IRAS back in the 1980s where apparently they caught in a protoplanetary disk of two planetesimals hitting each other. And it caused a huge infrared flash that lasted for a year. And the scientists, measured it for a year. And I was around at that time. I did not hear about that. I didn't see it in Sky and Telescope. I didn't see anything about it.
I'm sure I reported it on it, but it doesn't, I don't remember it offhand.
Well, this would have been around 1986 somewhere.
Oh, okay.
No, so this might, this is when we were, watching Carl Sagan.
Right.
So just finding those kinds of things that you didn't know about that remain somewhat mysterious, but cool, because what are the chances of just having to look right there and see that? But that happens. Another one would be, apparently there was an observation in the 90s of a flash on the backside of Jupiter that reflected off of one of the moons, and the researchers caught it, and the best guess is that this was lightning, giant lightning bolt that actually flashed off of, I think, Io, and was actually seen as a brightening. And it's those stories from within the history of astronomy, these little anomalous weird things that populate it that really excite me. But the thing is, they're happening every day now in astronomy. I mean, there's so much unexplained.
Like AI, it's too much to stay on top of.
And it's going to get worse as AI integrates itself into the study of astronomy.
Oh, yeah. Oh.
I mean, imagine just what we have now, being able to search data sets. And you think about poor Clyde Tombaugh sitting there with his blink comparator, discovering Pluto painstakingly in these photographs. A computer can do that in seconds.
Yeah, you send a machine learning algorithm into today's Vera Rubin data, however many petabytes were downloaded today, and say, what interesting thing happened today? And it's like, oh, I found you 17 new asteroids, 30 new comets, and I found this supernova, and then this thing over here that I don't even know what it is. Human?
Planet 9.
Yeah, I found you Planet 9.
Yes. Well, I almost expect that, because if it's there, it's going to find it with especially with the Vera Rubin telescope.
Yeah, if
there it's going to
exists, Vera Rubin will find it.
Yep, if it does. And then if it doesn't, then we get to ask the question is, why are all those asteroids skewed like that? That seem to indicate it. And there's nothing
Remember
there.
that primordial black hole idea that's ridiculous?
The primordial black hole idea. Yeah, that actually scares me worse than the presence of an alien civilization. So say we have aliens here. To me, that automatically means we live in the zoo hypothesis by virtue of their superior technology. So that's about the scariest thing.
We've agreed this before, that the one that
we both fear. But the next
is the zoo hypothesis.
A real close second is the presence of a black hole anywhere near us.
No, but it's going to have the mass of Planet 9. It'd be fine, and it's in stable orbit. Don't worry about it.
I know, and it gives us an unprecedented opportunity to study a black hole up close, but...
Yeah, and eventually use the Penrose process to extract energy out of it. No, this is all good.
Yeah, we could turn that into... Yeah,
this is our black hole. This has been a teammate since the formation of the solar system. It's ready to help. It just is waiting for us to fly out and introduce ourselves.
Well, there's the idea of a Kugel Blitz, where you could actually use a black hole like that to power a starship, and ideas like 100%. That, far future ideas. So it would be a fortuitous thing to have a black hole in the solar system of that size. But I still can't get past the gargantua, one of the...
that's 150 million times the mass of the sun. Totally different concept.
Now, just to go in a different direction, because it popped in the movie Interstellar popped into my brain, which is the most maddening movie ever made because it could have been so good, yet they messed it up and showed some very unrealistic planets. What is the most realistic space movie you've ever seen?
It's probably The Martian, I would say, but it had a bunch of problems.
Yeah, but they cropped up afterwards because, as I remember, didn't the perchlorate problem come up after Andy Weir wrote the book?
No, I mean the first problem was just the windstorm at all causing any damage. Like the wind, you couldn't fly a kite in a hurricane on Mars. The wind is 1% the atmospheric density of Earth, and so it
doesn't have any oomph.
It just has no oomph. Yeah,
it's got speed, but no oomph.
Yeah, so you're not going to get that kind of damage from the wind that they got in The Martian. And then the other thing, and this is the part that's weird, is at the very end, the way he uses to fly out of the spacecraft by knocking a hole in his glove is the thing that Andy Weir ridiculed in the book as a bad idea, and they came up with a much better idea. And yet, I don't know why they didn't use it. So in the book, he used a fire extinguisher, and in the movie, he punctured a hole in his glove, which would be really difficult to fly with.
Great, both a great movie and a great book, though. I really enjoyed them both.
Yeah, but I think just the level of detail. I mean, what is great is that Andy Weir put in the work, did the math, and came up with a lot of really clever ideas that had never been thought about before, but implemented them in book form. And then they made the movie, and I'm going to watch it tonight. I'm excited again. I'm going to go watch that with my wife tonight, I think.
Yeah, I might do the same because it's been a while since I've seen it.
Yeah, and it's so good.
And the thing is, I think I only saw the movie once.
And I love the attitude of everybody in the movie. Like we just finished watching Ted Lasso, and it's like such a heartwarming show. And everyone is competent, and everybody is nice. And in The Martian, right? Everybody is competent and everybody gets along well, and yet they have just enormous problems to overcome. But they do it through competence, which I love.
Yes. Yeah, that's the nuts and bolts sci-fi, essentially. Well, everybody take a look at Universe Today. Fraser's been doing that for many, many years.
Almost 25.
Almost 25 years of Universe Today. And then also Fraser's YouTube channel under his own name, which needs no introduction. We all watch it. Everybody check that out. And we are out of time. Fraser, I hope
and sign up to my newsletter.
Oh, yeah. Newsletter.
Universetoday.com/newsletter.
And what does the newsletter cover? What do you get?
So it is an overview of every single space story that I've seen this week. So it's sort of broken up into a couple of chunks. The main chunk is a nice picture and description of each interesting story that we looked at and we're covering on Universe Today. But then I also have this laundry list of all of these other links that I saw to press releases and other people's reporting of really interesting stories. So it's like the most comprehensive list of everything that I thought was relevant this week in space. My hope is like if you're signed up to a bunch of newsletters and you had to choose one, you had to pare it all down to one, that would be the one. Mine.
And tell them what it costs.
It's free and there's no ads.
It's free.
Yeah, totally free. It's no Substack. I'm not going to ask you to subscribe. Completely free.
And there's no AI.
No. So we are playing around with ChatGPT, but in the most mundane ways. So we have a gadget that we've coded up with ChatGPT that compares one article, essentially fixes orphaned articles that are in our database. And so it finds one orphaned article and asks if this is a duplicate of this other article over here. And if it is, then we merge the two together. So the joke that Chad, our programmer, uses is like, I don't need a robot to do this job, but I want to make a robot do this job.
Well, for mundane tasks, I have no objection to how we use AI right now. It's just that if eventually it gets to the point to where if you're writing an article using Chat GPT, you have to fact check it anyway.
Oh, it's as a writing tool is worthless. Like as an actual gadget that you could use to create text for a news website, it has no place. You could use it as a brainstorming partner to maybe suggest some avenues for additional resources that you haven't thought of, but that's about it. No, I every time I've tried to see if I can see how good it is to summarize stuff, it's pretty bad. So don't worry.
And it has no voice, it has no.
No, I know. Yeah. Every
voice,
time I write it, every time I have it summarize something, I'm like, oh, this is just so anodyne. This is awful. So yeah, don't worry.
Canned.
Yeah, totally.
No heart, no soul,
yeah, exactly.
No heart.
But I mean, this is just wait for 2 papers down the line.
Yeah. Well, by the end of the year, who knows?
Yeah.
Maybe it'll have more heart and be more compelling.
Yeah, it's inevitable.
Yeah.
It is inevitable that it will be dramatically better eventually.
At almost everything. Where I think the problem is that it's going to have problems when it has to interact with the real world because robotics is behind with that.
Did you see the video where someone had a large language model learn to play Minecraft?
How good did it do?
Yeah, and it really well.
Really?
And it built up a bunch of tasks. So it had to learn how to play the game, and then it started to discover recipes and started to explore the world and gave itself goals, building, fight an ender dragon, things like that. Yeah. So it has the capability for the first glimpses of agent-like behavior. And then the other video that I saw was this AI learning to make a dog walk, one of those robot dogs. And you just watch it squirming around on the floor. And over the course of about an hour, it's running around the room.
That's how it goes for me when I get up.
Yeah, exactly. So I think, feel free to move the goalposts as many times as you like, and AI will continue to squarely kick balls through the goalposts every time.
Is it well? It's a brave new world.
Yeah, it's coming fast and furious.
And by the next time we talk, Fraser, it may be 2 AIs that sound identical to us, and it's only a few months from now.
Yeah, exactly. Thanks, Sean.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice.